All right, it is 6:30 a.m. Pacific, so let's begin. Oh, hi, everyone. Welcome to the first official working group meeting of the newly formed Oblivious HTTP Application Intermediation Working Group. We are your chairs, Siobhan Sahib and Richard Barnes. Welcome. And we have multiple note takers. Thank you all for volunteering. And for JavaScribing, Richard and I figured that we can just keep an eye on the chat and relay any questions. This is the note well. Please read carefully, especially if you're this is your first IETF meeting. But even if not, please always be sure to be mindful of the note well, and also the IETF Code of Conduct as laid out in RFC 7154. Folks are expected to be courteous, not engage in personal remarks, mindful of diversity, and contributory. And this is our agenda, and we have a 1 hour slot. Reminder that the session is recorded, and the blue sheet attendance is auto-generated. Please keep video and audio off in case if you're not presenting or not recognized in the queue. And to enter the queue, there should be a button over here, which is a raised hand icon to join the queue. So please press that in case you want to join the queue. I'll pause here for a second to see if anyone has any comments on the agenda or wants to change it in any way. Please join the queue. Going once, going twice. All right, so if not, Chris, you're up. You can stop my slide share.
Okay. Just to confirm, you can see the slides. Great. All right. So thanks, Siobhan. This is just an overview of Oblivious HTTP. I'm still going to refer to the protocols of Oblivious HTTP, even though the working group has probably one of the best names we've seen in the IETF for some time now. This is primarily led by Martin, but I've helped him out a little bit along the way. Okay, so the problem statement for Oblivious HTTP is quite simple. There are many cases where you have clients interacting with servers, doing very simple tasks, like performing, a DNS query or executing a safe browsing query, in which in interacting with the server, they're revealing a bit of sensitive information. The actual data itself is sensitive. And by virtue of connecting directly to the server, they're also revealing their identity, that is the IP address of the client directly to the server as well. And for reasons that should be obvious, this sort of exposure is not great from a privacy perspective because it allows the server, upon interacting with the client, to link both data that the client sends and potentially also receives with the identity of the client. So if you consider the case of the DNS queries, this allows, say, for example, a DNS recursive resolver to collect effectively the browsing history of clients. And they may have, policies around how how that data is managed, but essentially it's not great for the data to be collected or available in the first place. And there are a number of other applications as well. It's been discussed on the list. For example, uploading telemetry data from a browser or any other application to a server, where the telemetry data might have sensitive information about that particular client's experience using a web page or doing some other activity, wherein you don't want to link that particular data with a specific client. And in general, there's plenty of applications and scenarios where we have these sort of transactional, single request response protocols or exchanges taking place, in which the exchange itself does reveal sensitive information. So Oblivious HTTP is all about trying to address this particular linkability problem. Of course, there are a number of ways you could address this without any new protocol. For example, you could use a general connection-oriented proxy like Connect, as is already standardized, or Mask or Tor. But it's often the case that these connection-oriented proxies have much stronger requirements, much stronger privacy and anonymity requirements in practice. Tor, for example, has multiple hops that clients go through in order to further obfuscate and make sure that linking a specific client to a specific target and eventually connecting to is hard in the presence of some very pervasive active attacker. And as a result of stretching things out or adding more layers or hops, there's more overhead added to the protocol, which is problematic because typically these transactional exchanges that take place for DNS queries, for telemetry uploads, typically are just a single round trip. And sometimes, especially in the case of DNS, they're very performance sensitive, especially if you're going to do a single request before trying to connect to a particular server. So if you wanted privacy using these existing technologies like Mask or Connect, what have you, you'd have to trade off effectively performance, or you'd have to make a trade-off between sort of performance of using this particular proxy protocol and privacy. You could, for example, get great performance with Connect or Mask if you kept the connection open for a long amount of time and then just sent these single request response queries over that long-lived connection. But then you'd be allowing the server to potentially link these multiple queries or these multiple requests over the single connection, even though the server might not know who you are, which is less good from a privacy perspective. Alternatively, if you wanted to break that linkability, you'd have to stand up a fresh connection, a fresh tunnel every single time, which does incur a performance penalty. So in general, this trade-off is not great, especially for performance-sensitive applications like DNS and other things. And it's unnecessary, it turns out, as is exemplified by Oblivious HTTP. You could also go down the route of using a specific application-specific protocol for, breaking this linkability. So in the case of telemetry, where you're, trying to collect some information about, what the browser's user's experience is like, you could collect this data in a privacy-preserving way using something like PRIO or privacy-preserving measurement. There's a blog happening later this week I encourage folks to check out. But these inherently are more complicated protocols involving more parties, and it requires infrastructure, non-trivial infrastructure that is not currently there. While it's also true that Oblivious HTTP requires new infrastructure as well, it's significantly simpler in retrospect. In the case of PRIO specifically as well, these application-specific protocols add delay. You can't just collect the data instantaneously and then look at it. Whereas with the protocols that we're talking about here in Oblivious HTTP, DNS, state browsing, what have you, it's available immediately. And it necessarily must be, especially for DNS, because again, that's a very performance sensitive protocol. We need the response immediately in order to connect to a server. So all that is to say, there are existing techniques to address this particular problem, but they don't seem particularly well suited to the applications that we have that we're considering here. And this is where Oblivious HTTP comes into play. It's a very, very simple message-oriented proxy between client and server that combines two well-known things for achieving privacy and breaking this linkability between client and identity. The first of which is a network proxy between the client and the target, we'll call it, that exists to obfuscate or hide the client IP address or its identity from the target server. And the second of which is public key encryption using HPKE to hide data from the proxy itself. So the proxy is effectively sending messages back and forth between the client and the target, but it can't see the contents of any of these messages because they're encrypted. That's the gist. And here's just a sort of quick overview of how it works, just to, in case you're not familiar with it. So the typical arrangement is you have this client, proxy, and a target, and then typically, resource servers beyond a particular target. I sort of separated them here because the target has a particular role in terms of the actual encryption and decryption that takes place, and the resource server is the one that actually has the content the client's actually fundamentally after. So before anything happens, it's assumed that the client sort of discovers some way, mechanism out of band or not specified in this particular document, the target HPT configuration. That is to say, the public key that the client will use to encrypt information to the target server. Then opens up an HTTPS connection to the proxy, fairly straightforward. And then over that HTTPS connection sends a public key encrypted HTTP request, which is then forwarded along to the target server, who decapsulates it because it has the corresponding private key, revealing the HTTP request, and then it goes off and gets the resource corresponding to that particular request, generates a response in return, or gets a response in return, and then simply encapsulates it and sends it back to the client through the proxy. So fundamentally, what we have here is a simple request response encrypted in each way. And if the client was to send multiple of these, each of them would be sort of unlinkable from each other from the perspective of the target, because all the target sees is a single TLS connection to the proxy, and then multiple encrypted requests or queries coming over it. It doesn't know whether or not they're coming from the same client or not.
Hey, Chris, quick clarifying question. I noticed you've drawn this dotted box around the target server and the resource server. Does that indicate that, in principle, those two could be operated by the same entity or could be instantiated on the same device without undermining the security guarantees we're after here?
That's correct. Especially in the case of DNS or Oblivious DOE, which is like the predecessor to this work, it's advantageous for the target server and the resource server, which is the recursive resolver in this case, to be operated by the same entity to minimize performance penalties involved. There's no, again, as I was saying earlier, I've only separated them for the purposes of separating the roles that they play. The target is responsible for the cryptography, and the resource is responsible for the application data bits. But they can totally be the same box, the same logical entity.
Thanks.
Yep. Thank you for the question. So if we revisit if you think back to the initial slide, wherein the server previously saw both the data and identity, quickly convince you that this is no longer the case in this particular protocol, assuming non-collusion requirements I'll get to in just a little bit. So it should be obvious that the client knows both the data that wants to send and the data it receives, as well as its own identity. Proxy, however, though, because it's just sending encrypted request and response between the client and the target, all it sees in clear text are the identities of either end. So it knows the client that it's engaging with, and it knows the target that's it's sending data to on behalf of the client, but it doesn't know anything about the data beyond that. Modular like length of the encrypted data and whatnot, but touch on that a little bit as well. And then the target equally sees just the identity of the target or the proxy server that's engaged with, as well as any of the client data that is the encrypted, or rather the decrypted request and the response that's produced as a result and eventually sent back to the client. So importantly, no single entity beyond the client has both the identity and the data, which is effectively what we're after here for the various applications that we're considering. So the threat model is fairly simple. It assumes some trust between parties that are engaged in the protocol. So for example, the client in its configuration and selection of a particular proxy, it trusts that the proxy is not obviously just revealing sensitive information to the target, like not just sending along, the client IP address and an HTTP header along the request. And the target also assumes that the proxy is, taking measures to ensure that it's not overloading. The target. The proxy as a participant in this protocol, making sure that the IP address is hidden from the target, has a role to play in the exchange and completion of a single transaction, and as a result, also has a role to play in ensuring that the system is available and not abused. From a, collusion perspective, the core requirement is that the target does not, collude with, share data with, whatever, with the proxy itself. Because if you did have, both of these entities controlled by the same by the same actor, they could just put the pieces together and figure out who sent what, which is obviously not great. But in the sort of the configuration and deployment models that are under consideration, this property sort of falls out. And I was mentioning earlier that the proxy does not see anything about the application data, with one caveat, and that is, I guess, properties of the ciphertext, including the size of the ciphertext, when the ciphertext was sent in response, which means that things like traffic analysis, how plaintext should be padded before encrypted, whether or not timing is of concern in these exchanges, is not discussed in the draft and out of scope, simply because I don't think we have a good answer for any of these things that is sufficiently generic and useful to all application protocols. There are some existing drafts and standards rather that discuss how to use appropriate padding for the purposes of minimizing information leakage in encrypted DNS. I believe based on some work by DKG and others. So for specific application protocols that want to use Oblivious HTTP, they can just follow that specific application guidance. As a practical matter in using Oblivious HTTP, there's a number of things to consider from an operational perspective. I think the very first thing to make abundantly clear is that this is an application-specific proxying protocol. So I've mentioned DNS, I've mentioned telemetry data uploading, I've mentioned safe browsing queries as well. It is not meant to be a general purpose proxying protocol for which we already have solutions if that was something you desired, like Connect, like Mask, like Tor, and so on. Importantly, also that the discovery and configuration of what clients, which proxies a client will use, as well as which targets clients will engage with across these proxies, is out of scope of this particular document. The main idea is very similar to DOE in that we're simply specifying the protocol mechanics and leaving the deployment considerations to subsequent work and subsequent, I guess, effort either in this working group or elsewhere. I forget exactly what the charter says about this, but anyways, it's not in this doc. As mentioned earlier, because there is some relationship between proxies and targets with respect to keeping this sort of service available and running. Proxies do need to engage in some sort of load management to make sure that they're not just abusing and overloading the target and taking it offline. I guess finally, as a practical matter, because all of the public key material is sort of static, it's distributed out of band, discovered out of band, and configured on clients. It's possible for proxies to take encrypted messages under these static keys and replay them. And so targets need to targets need to ensure that they are injecting fresh randomness into every single response that's produced in response to an encrypted request. Now the protocol does dictate that this happens, but care needs to be taken nevertheless to ensure that randomness is fresh. There are there are at least two implementations that we're aware of that are interoperable, one of which was written by Martin, another one was written by me. And there is a test server up that you can interact with, a test target server that you can interact with that will simply spit out whatever bytes you happen to send it in an encapsulated HTTP request. So if you're interested in standing up an implementation of a client or a proxy, you want to make sure that you're interoperable. I guess let me know, or send a message to the mailing list, and we can share details in terms of like how to use this thing. But it's there, ready to be hit. And with that, I think I'll pause for any technical clarifying questions. And assuming we get through all those, I'll turn it over to the chairs to deal with this question. Tommy, go ahead.
All right, hello. Yeah, thank you for the presentation. So one comment I just wanted to volunteer that I did recently implement the protocol from the drafts, both this and the binary HTTP messages. And I think, yeah, the specs are good and definitely useful and ready for adoption based on that. I did have a couple clarifying questions based on that that I'll just quickly ask. One of the things that wasn't obvious initially reading through the doc that became obvious in implementation is the fact that the proxy has to have like a pretty static mapping to like when you give it a request, where is it supposed to go in the back end? And there's a fair amount of state that's not mentioned there. So it'd be nice to see a bit more because that's a piece of the architecture that wasn't really clear. But then the other question I have, and maybe this is the one we can address now, the part about binary HTTP being the body of this seems to be, you know, as there are different documents, pretty disconnected. And like in Odo, you know, we didn't actually have the interior of the oblivious message be HTTP. It's fine for it to be HTTP, but in the current document, we are specifying like this payload always is a binary HTTP message. It seems that both the client and the target could decide to put something else in there. Is there any reason we need to restrict it to that? Or can this really just be a mechanism where we have oblivious bodies that we send over HTTP and we don't really care what's in them?
I think the latter, and the document is, at least the oblivious HTTP document is sort of written in that particular way. As you point out and as you observe, that is, it deals strictly with the encapsulation and decapsulation mechanism. Doesn't make any sort of that I can recall stronger requirement in terms of what is actually in the encrypted payload. So yeah, it seems perfectly reasonable to me from a technical perspective that you know, this just be a generic encapsulation mechanism or encapsulation layer for things that the client and target agree upon. Oblivious or binary HTTP being, you know, the one that you would most likely use. And on your, I guess your first question regarding sort of proxy configuration, yeah, I agree. That certainly more information could be, I guess, included with respect to what state proxies need to keep in order to route requests from clients to particular targets. As you know, in oblivious DO rather, we sort of put the state on the wire. So clients would specify effectively the route via the request that came into the proxy. But oblivious HTTP, the spec doesn't require that to be the case, although the two are somewhat functionally isomorphic. And we can just add some rationale to the current design in the draft. If I could ask that you file an issue to that effect against the draft, that would be great.
That's good.
Thank you. Richard?
Hi, yeah, I just wanted to in-queue for a brief chair note from the chairs that on the scope of what we're talking about. There's been a bunch of discussion about collusion and proxy selection in the chat, and this is just a reminder from the BOF and the charter that the initial protocol we were to develop does not have those things in scope. So the protocol starts from an assumption that the client has selected a proxy server and a target server that it assumes are non-colluding. How the client makes that choice is out of scope. You can imagine a variety of ones ranging from fully automated discovery to highly manual configuration. That is not the business of this working group. So any discussion of how we so it's up, the protocol's job is to make sure those entities are identifiable to the client and probably authenticatable by the client, but not to talk about how they are chosen by the client.
Thank you, Richard. Andrew?
So I was going to exit the queue, but I'll ask the question anyway, which was, what can we do to try and avoid the problem of colluding proxies? But noting Richard's comment, you might want to ignore that for now, but I think it is a problem that at some point we have to address. Otherwise, we're giving the illusion of privacy but with absolutely no guarantees of anything whatsoever being provided to the end user. So from an end user point of view, I think that's hugely problematic.
Yeah, I mean, it's a good question, and I'm going to punt because for now it's out of scope. But when we start talking about dynamic configuration of these things and actual discovery protocols, I think we'll obviously need to address that. But for the time being, with the assumption that the configuration falls from the air and the participants just run with it, I think we can safely ignore it. Stephen?
Yeah, so I don't know. Richard might call this out of scope, but I don't actually believe it is. I mean, I'm not asking for discovery. I'm asking for detection of collusion. I do think we ought to look at is there any way that we could make it possible for some kind of transparency about collusion that might be post facto detected and only if you actively probe or something. But I think if this protocol provides no mechanism at all where collusion could be at some level detected, even if it's post facto, even if it's statistical, then I think again the overall benefit kind of is going to be kind of hard to see, given who's likely to put up these proxies. So I would. It's not about the ready for adoption call, but I think given the discussion in the chat, it's worth recording that if we could have some kind of transparency at some level, that might help people understand whether collusion is happening in the real world or not.
Sorry, I'm not closely following the chat, but the situation to me seems very indistinguishable from, or trying to detect whether or not parties are colluding seems very similar to trying to detect whether or not, say, a TLS terminating server is just like posting its keys to Twitter or
Sure, but I guess my counter argument would be that we would have said the same about the web PKI before certificate transparency, probably. But given certificate transparency, that's no longer true. Again, but not in an individual transactional kind of level, but at some kind of if somebody clever goes looking level, it's some kind of technical auditor type thing.
Yeah, I maybe.
Jumping as chair here, it's like, Stephen, if you have concrete proposals here, by all means, feel free to propose them to the list. But yeah, I don't think this is something that's clear in the charter as a requirement and needs to block the main protocol document. All right, so I think we've drained the queue there. We closed the queue to try and manage time here. So I think, Martin, it is your turn to be up.
This is the point that I wait, and it's working. Okay, so Tommy made a point about the content of these encapsulated messages, and I just wanted to go through some of the stuff that we've done thus far for carrying HTTP messages, so that you're able to use generic HTTP in order to get the messages through. I've opened an issue in response to Tommy's query, and that is something that we can talk about later if we get past the initial more important issues. But for the moment, the protocol is fixed to the use of this binary HTTP message encoding. And how do I get to the next one? All right, there it is. So the idea is to cover entire HTTP messages to the target resource. Everything is included, including all of the routing and encapsulation, the method, the URL, and it uses a binary encoding, which is unambiguous and easy to process, and uses a lot of the lessons that we've taken from HTTP 2 and HTTP 3 in making HTTP messages. So it's not those protocol formats because, well, they're really complicated, and things like HPAC would rightly scare people away from implementing them. Also, some uncertainty about whether the compression in something like HBAC is safe to be using under the sort of adversarial conditions that we're using. So forget that, just put the control data in the header fields straight in the message uncompressed, and then make a few allowances for things that we do know that we need, which is things like padding and the ability to stream requests and responses. There's two mechanisms in here. There's a fixed length one for those people who know how long every piece of the message is going to be before they put it on the wire, and for those who don't, which allows for construction of messages that come in off another medium and also sending them onto another medium. That little bit of flexibility is, of course, negotiable. I have an implementation of this. I heard that Tommy has implemented some of this as well. It's relatively straightforward. I think it was about 300 lines of code in Rust. Not that difficult. Most of the hard part of writing this code was parsing HTTP 1.1 messages, which is what you see at the top of the slide there, or rather in the middle, because those are terrible in various ways. So I'm here to really just say this is probably not something that this working group wants to take on. We should take on the encapsulation part and all of the difficult questions that people have raised about how this all fits together. But instead we ask the HTTP working group to take this sort of work on. I've gotten some feedback there. This is in the right direction, but that's all I have.
So Martin, just to clarify, and I guess for Chris as well, it seems like OHI is not really useful if we don't have this format, right? Because it needs something of this general character to get its job done.
Yeah, so it depends on the extent to which we allow for Tommy's idea of generic things to be facilitated in the framework. So it doesn't really carry HTTP at that point, but you can carry other things over HTTP. And so if we make allowances for that, we could get this to work. I think this is probably the right thing to do in terms of having carrying HTTP, and so I prefer that we do this. Then you can make a generic HTTP request, more or less, and then it works end to end.
So then the work split would be that this working group would develop a general intermediation, deliver this data through an extra hop protocol, and then the HTTP working group would make the here's how you generically encapsulate an HTTP request, and then if you put the two together, you end up with oblivious HTTP. Does that sound about right?
Yeah, that's right. And we can talk about what it takes to do generic stuff for other protocols over the top of HTTP, but we'll do the over HTTP encapsulation-y bits.
Yeah, it seems like we would at least need the semantic that, given the way the tunneling protocol looks, you would at least need a request response semantic for whatever you were tunneling.
Right. I mean, that's a limitation inherent in this, and to some extent, that's a limitation that we need to discuss for HTTP as well. One of the issues that I'd like to discuss later is whether we have some sort of streaming capability in here that would allow us to do more generic HTTP messages than what this currently allows.
All right, sorry, since I've injected my own questions, using my chair privilege a bit, we have a couple minutes, I think, before we hit our time to make the adoption call on the agenda. If folks have further thoughts to bring to the mic on before we take an adoption call. I believe we'll be taking adoption call on the draft that Chris introduced. Any thoughts? Mic line is open. Eric.
Howdy, yeah. These drafts seem like appropriate starting points for adoption. I do not care at all whether like the binary one goes to HTTP or here, and I trust that someone can work that out. I mean, it'd be exactly the same people in either location, so so it really doesn't matter. Richard, thank you for trying to scope this as narrowly as possible. You know, all the issues that are being raised here, frankly, were relevant adoption call, so I think the adoption call answers them. I don't think we don't need to redebate them.
Watson?
I think adopt the first draft and punt the binary message draft to HTTP. More people who know about HTTP are in that group than this group.
Yeah, that was the thought. There are some fiddly bits in here. It's not particularly complicated, but it's worth getting those people to do the work, I think.
Yeah, I'll want to check the charter to see if it makes sense to extend this beyond HTTP. But I think even if we keep this working group HTTP indirection specific, we can still take the dependency on the HTTP working group for the encapsulation. All right, last call for further comments and discussion here. Okay, I think we chairs are working on getting this call set up. Siobhan, do you have you figured this out yet?
Say it again, the actual call.
Yeah, so I'm gonna try and do a show of hands here for adopting get the draft name. Do a show of hands on adopting the Oblivious HTTP draft as a working group item. Okay, I'm going to start the show of hands now. Please raise your hand if you think that the working group should adopt the draft that Chris presented as the starting point for fulfilling our charter and milestones. And click the do not raise hand button if you have concerns about adopting this as a working group, as the starting point for our working group deliverables. Okay, so clicking the button now. All right, things seem to be equilibrating. Closing the session now. So that seems like pretty strong agreement that we're going to go forward with this. Does anyone from the not raise hand camp want to come speak about what what your reservations are? Okay, so we will take this out and confirm it on the mailing list. Feel free to contribute to any discussion there. If you've already raised your hand here, there's no need to reconfirm it there. We'll just cover any additional issues there. But it looks like we have pretty good consensus to adopt this Oblivious HTTP draft and get to work on it as a working group item. Thanks all. So with that, our remainder of our agenda is set aside for looking at issues related to that draft. I think, Martin, you were going to share a screen to walk through issues there. I have approved your screen share, I think.
Well, that's working really well for me. I can't see anything working right now.
Can you try again, Martin?
I will try again.
It's getting sort of a Jasper Johns vibe from that. Maybe Silhouette. Wow. There you go.
All right. If at first you don't succeed. So I sent an email to the mailing list. I didn't get any responses on this one, but I put 5 of the issues that I thought we might discuss here briefly. We only have 20 minutes, so feedback would be useful in any form. The first question is really to what extent we're able to make request and responses more generic. So probably the most obvious thing we could do to make request and response more generic and be able to support a larger subset of HTTP capabilities is to make them streamable. One of the things that would allow is you could have things go via the proxy that included things like 1xx status codes or long message bodies that could be processed incrementally and those sorts of things. This comes with a cost, primarily some sort of framing and a little bit of complexity, although I think we can manage the complexity reasonably well by tweaking things like AADs in the AEAD application or HPKE. So I'd like people's thoughts on this one. And I'm apologizing, but I can't see the queue now.
Ted?
Ted, go ahead.
So I guess this is sort of a base question in how you're presuming this. If I currently have a setup where I have 3 of these proxies configured, one of the things I can do is I can send information to 1, and my next query to 2, and my next query to 3, essentially round robining the queries, even if they're to the same service via different proxies. And that would work fine with the current set of mechanisms because there for things like DOE was where the responses coming back are not meant to be linked to any state on the server. I'm assuming that if you made these requests and responses more generic, then you would have to then not use a single, GET or POST as the unit here, but you'd have to have some more generic way of thinking about what the interaction set would be. And I don't think I know what that would be. And I wondered if you could describe that.
So I don't think we're looking to change the basic interaction model here. So you would retain the same capabilities as before. The only difference would be that when you construct a request or a response, you would be able to construct it in such a way as that pieces of it would be available for processing as opposed to the entire thing. I don't know if there's any desire to go for anything far more generic than that along the lines of what you described. Does that help?
So
it'd still be request response and all of that. So you would get correlation of request with response.
Okay, but you would still say that if I wanted to switch to the next proxy in my list of 3 for the next request and response, I would be able to do that. It would just be that the first response might have continuation in it, like with a 100.
Right.
Is that correct?
That's right. Yeah, that's right.
Thanks for the clarification.
Tommy, should I go next?
All right, thank you. Yeah, on this, I guess I'd like to understand what specific applications would need to have this more generic format. A lot of what I've been thinking about is we have these oblivious requests for pretty stateless, simple request responses. For more complicated things, we can just do, multi-hop mask proxies, because we have to have stuff for that anyway for being more stateful. Can we get away without having this complexity and just say, yeah, there's a limited set of things and all the applications we know of will need this smaller set?
I think this is a reasonable approach to take. It's the one that I took originally. That wasn't by accident, but I thought it was important to ask the question because others have.
Mark? We're not hearing you, Mark, but I see that you have the audio privilege. Still not hearing anything. And you're offline now. You're online.
Modern technology.
I think maybe we can move on and we can come back to. Sorry, Jim, go ahead.
I see Mark back in the queue, but maybe I'll vamp for a second while he gets audio going. So just to try and throw the decision into higher relief here, Martin, is the choice here between having more flexibility and capturing the entire range of interactions that HTTP allows on the one hand, and on the other hand, having a simpler interaction model, say a single request, single response, and declaring that certain HTTP patterns cannot be done over this channel?
Yeah, I think that's right. I don't think anything here forecloses on the possibility of defining a new format to do more complicated things. So we could even decide to do both, but it really is keep it simple, keep the overhead low, or try to get more of the streaming capabilities of HTTP, which are used in some contexts. But as Tommy says, because of the narrow application domain, we could reasonably say that those are out of scope.
Yeah, I think personally, like speaking as an individual contributor here, not a chair, I think my preference would be to follow that latter path and keep things simple in this iteration, even if that entails basically disabling or turning off some HTTP features. And putting chair hat back on, I'll pass to Jonathan.
So maybe this is just a stupid question, but does this create a vector whereby you can more easily make a server store a lot of state? Like send lots of part 1 of 6 messages?
I think that was true already, although it shifts where you maintain that state. So in the current design, you can send part 1 of 6, but the server would not be able to decrypt it. So it would be holding the ciphertext. And this one potentially changes that to shift to the application domain. So if that's important, that's important. I don't know.
Thanks.
Mark, you want to try again?
Can you hear me now?
Yes, we can.
Okay. All right. It's like this WebRTC thing isn't done or anything. Yeah, I was one of the folks who was asking these questions, and I don't have direct, strong feelings about it or concrete use cases. This was just one of the things where it felt like we often put these artificial barriers in place, because of design constraints, and then applications immediately trip across them. So we should do so really consciously if we're going to do it. And also, to me, it really spoke to the naming issue. If we're going to, not allow full HTTP to come through this protocol, we probably shouldn't call it oblivious HTTP or anything -HTTP, which we'll probably get to that later because that's a big freaking bike shed. But that's where I was thinking with these questions was if somebody comes along and wants to do an application that requires larger responses, for example, or 1xx, non-final responses, you're going to want this pretty quickly, and it's going to be pretty constraining for them.
Yeah. So I don't know if you missed this while you were struggling, but I made the observation that we can add new, I guess, media types in order to support different use cases.
So I guess that's the question as well. As I understand it, this is really a question for the generic proxying layer, or how you bundle up the crypto. I guess it's also a question for things like 1xx about the HTTP format. So how do you see this being reflected in the two different drafts?
That's a good question. I'd be looking for text on that. It's too early/late for me to be cogent on the specifics there. Yeah.
I mean, I'm fine if we decide that, no, let's keep it really limited. I just think that should be conscious, and then if we do, we should probably think about the naming.
Yeah.
Thanks, Mark. Mark, we still have, I think, a few minutes in case you want to talk about any other issues.
Yeah, I'm going to just talk to these ones, I think, rather than subject everyone to 4K screen shares.
If it helps, I have just a summary of each issue at the end of my slides. We could just pull that up.
Oh yeah, why don't you ask to
I will
present
do
that, or
that.
maybe I can.
I'll do it.
There we go.
Okay.
All right. So the next one talks about what additional data we need. And this gets into interesting questions about, well, two things, really. So Chris opened the issue, and I think I split it two ways. The first one, I think we're going to want to talk about the question of what information does the client or the server need to provide to the intermediary in terms of what's going on under the encapsulation in order for it to more effectively do its job. And my initial take on this and what's in the drafts is absolutely nothing. But Chris wanted to ask the question, and I think it's a reasonable one to ask, is there anything that we might deliberately expose to an intermediary in order for it to more effectively do its job? And that's really not something that I think we need to discuss here, unless someone has a stunning idea, but if it's something that people might want to think about. The other aspect of that I think we might want to discuss at some point is anti-replay capabilities. So one of the, I guess, more unfortunate properties of this is that the proxy becomes a potential source of replay attacks against a server, and providing some capabilities or some sort of facilities for doing that is not something that the draft currently does, but we might want to do things like put timestamps in messages in order to provide the servers with some tools that they can sort of hang their anti-replay protections off. Do people have opinions
Martin,
on that?
I just wanted to, if I may, add some color to the origin of the issue, just for people to have some additional context. Over in the ppm/priv group, or BOF, that body of work, we're effectively reusing HB key for public key encrypting data that could be easily fit inside of an HTTP request from clients to these servers. And it's been discussed a number of times that you might also want to compose or use OHI or OHTTP for the purposes of sending these messages. And in that particular protocol right now, there is some additional authenticated data that's exposed in the clear. So the idea was, could you potentially reuse OHTTP for this particular purpose, including some additional authenticated data, allowing one to deploy a proxy between client and server if you wanted one later on without any other sort of wire format change. But I agree with the pushback that has been discussed on the issue, that we don't necessarily want to be adding or exposing more things to proxies. But that was the origin.
Thanks, Chris. And sorry, just jump in. So we are at 4 minutes now until the end of the session. I just wanted to take a couple seconds here at the end, by the way, of wrap up and next steps. We've had a good meeting here, I think, getting people in sync, getting a good adoption call, a clear adoption call, which we'll confirm on the list. Now, as we work on burning down these issues and making progress on our new working group document, just wanted to see if folks would think it useful to have some virtual interims scheduled. So we could do something like have monthly or biweekly calls to go through some of these issues and try and keep up the pace here. Do folks have thoughts on whether that would be a good kind of pace, or what would be a good pace here? Or whether we should just keep things on the mailing list for now? Martin, Chris, as editors?
I have a preference for doing things in GitHub. Been there enough times that I know that the mailing list is fine.
Okay, so we can focus on async for now. Should real-time face-to-face be useful? We are always 2 weeks away. The IETF requires 2 weeks notice before we have a working group virtual interim. So feel free to propose such, and we can get something scheduled. All right, I think that is the last I had on my agenda. So I think we are done here 3 minutes early. So enjoy the rest of your IETF day. Thanks all.
Yeah, thanks all, and thanks again to our note takers and presenters. Have a good IETF week.